but you know, close enough. Some kind of veggie, and that was, I think that's the easiest veggie. Great.
We were in English class, and we were either doing a TWA or like working on some kind of test, and Mr. King put a picture of one of my old yearbook photos on the screen for the entire period.
You?
Yeah.
What about Chandler?
No. He did it myself and Vince Weezy.
From what grade? What grade was it? 5th grade.
What can I say? I was like 7th grade. I don't know. I was younger. That's all I know.
Alright, so if you look at number 18, number 18 says 2 minus the cosecant squared of z, and we're trying to get that equal to 1 minus the cotangent squared of z. And this one, you totally can pick either side. It doesn't really matter. So, what side did you pick? What did you get? How did you replace a piece or all of it? Ben.
So
Ben comes in late and still on task. What'd you do, Ben?
the first thing I did was I split the 2 into 1 plus 1. So that it was
Sure.
1
This
plus-
guy right here?
Yeah.
Alright, so he said with that 2, you're allowed to pretty much manipulate anything in this problem. Yesterday we had like that sine cubed, and we could separate that as being a sine and sine squared to get it to work. But he said this 2 can change into become 1 plus 1. Because 2 is 1 plus 1. So you're just changing the way the 2 is written. And then minus cosecant squared. Alright, Ben, why does that help you?
Because I know that there's an identity that has cosecant and 1 in it. But then I looked at the identity and it's actually cosecant minus 1. And so I put the 1 minus cosecant squared in parentheses and took out the negative, so it became cosecant squared z minus 1.
Okay, so he said there's an identity that involves the cosecant squared, and that identity is 1 plus the cotangent squared is equal to the cosecant squared. However, he's saying that this identity, if you take the 1 to the other side, you get a positive cotangent squared, and you get cosecant squared minus 1 instead of the opposite 1 minus the cosecant squared. So he factored a 1 out and put this in parentheses to change this to be cosecant squared of z and then minus 1. So just pulling out a negative 1. Again, that's an algebraic process. You're using factoring, pulling out, and that flips the signs. The other option, you could have solved this for cosecant squared, make it negative. So you could have taken the cosecant squared to the left and then the cotangent to the right, and that would have worked as well, kind of manipulating that identity a little bit. And then you can replace this cosecant squared minus 1 with, yeah, cotangent squared. Nice job, Ben. So again, you're taking a part out of the problem, and this isn't just the only way to solve it. So you could have definitely looked at this piece here, the negative cosecant squared, kept the 2 in front, and taken out the negative cosecant squared as well. So there's a couple of different ways, but it's involving that Pythagorean identity and kind of rearranging it. And then I think number 23 was the other one I heard. So looking at 23. 23 I think was similar to the one we did in class yesterday. So our goal is to take a subtraction problem, make it into multiplication. So we have cosecant minus sine, and that's supposed to become the cosine times the cotangent. Again, a couple of different ways depending what you see here, what you notice. Emma.
I did the multiplication side.
Okay, so using the multiplication side, what did you do?
I made them into fractions, so it's cosine x over 1 times cosine x over sine x. Then I multiplied those together, so it's cosine squared x over sine x.
Okay, so she's working with the right side here, changing the cotangent into the quotient identity, so that's cosine over sine, and then that gives us that cosine squared term. Once something is squared, Emma, which identity can we use then?
The Pythagorean.
Yeah, the Pythagorean identity. So once you have a squared term, then we can use the Pythagorean identity, which gets that subtraction sign in the problem or an addition sign in the problem. So one term, cosine squared, I'm going to change this into,
1 minus sine.
right, 1 minus sine squared. So that's how you can try and get subtraction or addition into the problem. By, again, going back to that identity. Or if you want to get it out of the problem, you go back to that Pythagorean identity as well. All right, Emma, so now we've got 1 minus sine squared on the top and a sine on the bottom. And yesterday in that problem that we did, I think we took the fraction and then we just kind of split it up because it has a common denominator, so we just separated it. So separating the fraction, a little crisscross action here, so 1 over the sine, and then there's a minus, and then we have sine squared over the sine. That's called decomposing a fraction, which we'll do in chapter 7. We'll really talk about decomposing fractions, breaking them down. So usually we find a common denominator and put them together. Well, we're going to have this huge fraction, we're going to start breaking it down. So 1 over the sine is the cosecant. The sine squared on the top cancels with the 1 on the bottom, and then we have the sine. So that kind of shows you opposite of what we did in class yesterday. In class yesterday, I think we used the left side when we did the left side, but this shows you how the right side also works, which Emily, I think, said yesterday about that. So I think you did the right side. Kind of just depends on what you see. Questions? So I like these problems because there's not one way to do it, and it's just like, what are you seeing? What are you thinking? So it doesn't have to be done the same way every single time. For a lot of the things that we do in algebra, there's like one way to factor a problem. But here, there's a couple of multiple things that you could do algebraically and with the identities, just depending on what you see. So we're going to go through just 3 more examples today, trying to practice a couple other identities. And then this will be like the last section that we go over with the actual notes in class. Thursday and Friday of this week, we're taking the 2-day test. So Thursdays is the easy day. You have a couple of identities that you'll be using. They're pretty straightforward, simplifying problems, not a lot of algebraically involved problems. And then Friday is the 5-day test where it's just 5 problems. They're a little more involved though. And they'll take you a couple of steps to kind of simplify them or verify them. So again, if you're not going to be here Thursday and Friday, Thursday's portion is 20 minutes. At some point tomorrow, see if you can get that portion done so that you don't have 2 to make up. So if you're missing Thursday and Friday, get that 20-minute one done. It should not take you more than 20 minutes, maybe 25. That's all they're going to have to take it on Thursday. So please get that done some point tomorrow. That's the easy day. 2 minutes. I'll time you, Jessica.
Okay.
I have a class that I can bring in. It's actually a really very good class.
Are we a good class?
Oh, yeah, really good.
Do you describe any of your classes as not good classes?
Yes.
This one probably.
And we're not one of those?
No.
Aw.
All right, so if you look, I'm thinking of page 10, they're 15. No, not 10. If you look at page 15, just see, look at the problem. Our goal is to get it down to 2 cosecant of theta, or you could try and start with 2 cosecants or theta and get it into that evil problem on the left. But just kind of see, what do you notice? Which side would you work with? I feel like it's pretty obvious you'd want to work with the left.
Are you just take the test now?
No.
Wow. Oh, I know. We're in class right now.
So try and break that down, get it equal to 2 cosecant theta. No, I don't have another version made yet, Emily, so. Stop. Very similar to this one. You can start with this guy and change this to 1%. Oh, nice. That was really cool. Such a good.
Yes. Even because Mr. Cose's autograph on it.
Oh, wow. Look at that.
Yeah.
No, I think we can get like that.
It's better from Mr. Rodak's autograph.
I taught him when he was in 10th grade. That was my first year teaching.
Whoa, really?
This is just like a little loop with a squiggle at the end.
That's so
Oh.
crazy.
So crazy. I was there like as a long-term sub for one of the
Yeah,
math teachers.
That bottom one in marker is his signature.
I see.
That's a good student.
Maybe it's a little squirrely at 10th grade.
He was probably
Did you
playing the
teach
super
Steven?
fun scale degree game.
Steven Rodak?
No, I haven't had any of the other Rodaks.
Oh, really?
Like none. I don't know. And there's so many of
I
them.
wanted to know how
It's
they
like the
compare.
spears. Like there's so many of them. But I get all the spears, but I got none of the Rodaks.
Huh.
And all the
Bad
pet
idea.
Myers. I had all the pet Myers. But all right. So, what would your mind think when you have a problem that looks like this? Grant, what does your mind think? How you approach this type of problem?
I decided to factor out a common denominator.
Yeah, common denominator. You got fractions. Let's use a common denominator. So, Grant, the left side you multiply by,
Sine theta.
and the right side is multiplied by.
1 plus cosine theta.
Okay. So on the top we have sine squared. And then foiling that right one, Ben, what do you get when you foil that? Sorry, Ben, I caught you off guard. What do you get when you foil?
I didn't foil it.
Oh, you didn't foil it. You just left it as is.
You get sine squared. Well, you get 1 minus cosine squared theta. No, no,
Right.
you did it
1
different
plus
way.
2 cosine theta plus cosine squared theta.
There we go.
Good job, Emily.
Thanks, Rick.
Wait a second.
And then on the bottom, we can just kind of leave this go for a little bit just to see what happens. You could distribute it through too, but I'm just going to kind of leave it sit there for a little bit. So the top foiled. Emerson, you must have done something a little different. Did you use a conjugate?
I did.
Yeah.
One of them.
All right, so getting a common denominator typically is stuff that you would do with fractions. After you have that common denominator, if you look at the numerator, are there pieces that you can pull together to try and use an identity, right?
Heck yeah.
Yes. 1
Yes.
plus, well, I tried to substitute in for the, I tried to substitute in for the cosine squared theta, you know, and the being cosecant of the variant.
Okay.
Just not how I did it.
All right, so he said he tried to substitute for cosine squared theta. Grant, what do you notice?
I added the sine squared and the cosine squared together.
Yeah, you can add those together because that identity said sine squared plus cosine squared is equal to 1. So if these guys equal 1, and there's already another 1 there, you're adding them together, you get 2. So they cancel, you get rid of them, but there's a number 1 sitting there, and that's being added to the problem. And then, what do you notice about the numerator, Jacob? W.
You can take out a 2.
Yeah, we could take out a 2 from that numerator, because they have a 2 in common. Since we left the denominator as that factored form, taking out that 2 enables us to cancel that whole group, because they are the same exact quantity. And 2 over the sine is the same thing as 2 times the cosecant. So again, that's just one way to work through the problem. You wish you were doing identities, huh? you could have worked through it a different way. Emerson said he used the conjugate, and that would have been another way to work through the problem by using the conjugate. So multiple ways, just depends on what you see. Questions? Second one's a little different. I think it's probably the most confusing one of the group, because you have those negative angles in the problem, and you also have a term that's squared. So we have the sine squared and then a negative angle. We have the cosine squared and a negative angle. And the first thing that I actually want you to kind of think about is that squared term and the negative angle. I'm going to pull the squared term and just kind of separate that 2. And this is more just kind of writing it just to think about it slightly differently. When you have that squared there, we stick it in between the sine and the angle, but it really means that that whole thing is being squared. It's a squared term. So writing it as sine squared and then a negative angle, or having the sine of a negative angle squared, is the same thing. That's what the term being squared means. That whole thing is squared. So doing the same thing with cosine, I'm just rewriting this to kind of just change where that squared term is located, or where that little 2 is located. So they mean the same thing. It's just kind of thinking about where that 2, what it's doing to the problem. So you're squaring a term. We usually just put it in between the word, the function, and then the angle. Bless you. All right, so why did I want to do that? Let's see what we would do with this problem. So what do you think you'd use first, Elena?
Well, I was thinking that a negative quantity squared is the same as a positive quantity squared, so don't the negatives just not matter, besides the one in between the two brackets?
Yes, so she said a quantity that's negative. So looking at the sine of a negative angle, this is really negative sine angle. That's what the sine of a negative angle is. That's your negative angle identity. And over here, the cosine of a negative angle is just a positive cosine. So she said if you square it, which is why I wanted you to pull that square out, so you're really thinking about what does a square do. When you square any quantity, positive or negative, it turns into a positive value. So negative sine squared is actually positive sine squared. That's what a square does to a quantity. So if you have a negative x squared, it really is a positive x squared. A negative 3 squared is really positive 9. The minus sign in the middle, that part doesn't change because that's just your separation of terms. And then we have cosine, and it's squared because that quantity was squared. So they both become positive even though the angle is negative because you're squaring a term. On the bottom, we have the sine of a negative angle, so that turns into negative sine, and then minus cosine of the positive angle. That's your negative angle identity. So the sine of a negative angle is really negative sine of a positive angle. The cosine of a negative angle is the positive cosine of the angle. Again, the minus sign was just in the problem. So now we have sine squared minus cosine squared, and then we have negative sine minus cosine on the bottom. And no, you can't just be like, oh look, sine cancels, cosine cancels, there's a minus there. Because it's not a problem that's in parentheses. You're not multiplying the problem yet. So you cannot just be happy and cancel those out. That is not an algebraically correct step. Emily.
You can split the cosine squared minus, or the sine squared minus cosine squared, and the sine plus cosine, and then sine minus cosine.
Yeah, you can factor that. Once something is factored, then you can cancel terms. But if it's not factored, factored means your problem should be multiplication, then you cannot cancel terms. So she said we could change this to sine minus cosine and sine plus cosine. Emily, what could you do to the bottom then?
You can take out a negative 1.
Yeah, pull out a negative. They're both negative, so pull that negative out. So the numerator, that's like having x squared minus y squared. That's a difference of 2 squares. When 2 terms are squared, there's a minus sign in between. They factor as sine minus cosine, sine plus cosine. Bless you. Now that things are in factored form, you are allowed to cancel them because we have quantities that are grouped together and quantities that are identical. So these guys cancel, You still have a negative sign outside here. So we're taking sine divided by a negative, so that's a negative sign. Negative cosine divided by a negative makes it a positive cosine. And we were trying to get this to be cosine minus sine. So after you get these to cancel, don't forget about that little negative. The top needs to be divided by that negative 1. Questions? So the negative angle, just kind of remember those identities. Cosine becomes positive, secant becomes positive, the other 4 are negative. So I believe there's just one final problem at the bottom. Or at the back, not at the bottom, on the back. And this says 1 minus sine over cosine equals cosine over 1 plus sine. This is one that you just pick a side. Doesn't matter. Half you can pick the left, the other half pick the right. Jesse, which side would you choose?
I chose the right.
The right, and what did you do with the right?
I multiplied it by a conjugate, so I multiplied it by 1 minus sine over 1 minus sine.
Yeah. If you choose the left side, you would do exactly the same thing, except you're going to use the conjugate of the numerator. So if you want to use the left side, multiply it by 1 plus sine over 1 plus sine, that conjugate fact, so that you can try and use one of those Pythagorean identities. And remember, you pick a side, stick with a side, it doesn't matter which side you choose. Or if you don't like one side, after working through it, you can't get anywhere, then go to the other side. Did you distribute cosine through, Jesse?
Yes, so I got cosine minus cosine times sine over 1 minus sine squared.
So we've done a good number of problems that involve the conjugate. Really easy method to use, algebraic process. And then Jesse, 1 minus sine squared turns into?
That turns into cosine squared on the bottom. So then you can take a cosine out of everything. The numerator and the denominator, so that's 1 minus sine over cosine.
So after you use the conjugate, change the denominator into cosine squared, which is why we're using the conjugate with those Pythagorean identities. The cosine cancels with one of those cosines on the bottom, and then we're left with 1 minus sine over the cosine. Questions? I think tonight's homework is a little more interesting than yesterday's. Most of the problems involve a couple of steps instead of just like 2. I'd say 5 probably, but still pretty straightforward. Jacob, you kind of skipped.
Well, there was.
A couple of them were, yeah, a couple of them are pretty interesting. You have 10 minutes. Take a picture of the book over there if you'd like. The answers are already there because you're verifying. You can always plug them in your calculator as like a y1, y2, and look at the table of values. But